So why do we bother with vector components? Well, let's draw a simple, again, an xy axis. So there's x, there's y. And let's again just use the example of displacement. So let's say I start from the origin and I walk a certain distance in a certain direction. So I change my position by this much, and I can denote that with this vector A. And then I decide to change my mind, and I now walk in that direction, and let's call that vector B. And I want to figure out what is the total change in my direction. So let's call this vector from there to there vector C. I want to figure out what is A plus B, or alternatively, how large is vector C and in what direction is it pointing. Now, remember I said any vector I can split up into two components. So let's draw a right triangle over there with this vector A as its hypotenuse. And let's first look at this triangle over there. Now, let's say we've got some angle with a positive x-axis, which I'm just going to call theta. But I can see already from this graph, if I want to express A in terms of two components, it's this much along the x-axis. So that distance is just going to be, let's call it AX, and it is that much along the y-axis. Right, very straightforward. Nothing too fancy. Let's do the same with vector B. Let's drop a line to form a right triangle. So now I will be looking at this triangle over there. If I want to figure out vector B, it is that much along the x-axis. Let's just call it Bx. And it is that much along the y-axis. Let's call that By. And if I now look at this vector C, I see that, hold on, if I take the tip of C and I drop a line to the x-axis, I get that this is, vector C is so much along x, and it's equals to so much along y. So do you agree with me? I can say, well, vector C is equals to so much along x, so this much along x, and this much along y. Right, everyone agree with me? Pretty clear? And this now gives us a mathematical way in which we can add any vectors. So if I want to add two vectors, all I have to do is first add their x components, and then add their y components. And then you can simply just leave it in a form that says, well, I've got so much along x and so much along y. You don't have to usually simplify it more than that unless I ask you how long is this vector, in what direction is it pointing. So this is why we need components, because mathematically now the problem boils down to, if I can calculate the x component of A and the x component of B, two simple numbers, I can add them together like any old number, and I get the x component of c. If I then add together the component of y, the y component of a and the y component of b, two simple numbers, I add them together and I get the y component of c. So we now get a mathematical way in which we can add together